everyone. We are from Group 4, here to present chapters 1 to 4 of Karl Popper's book entitled The Logic of Scientific Discovery. The first chapter under the introduction to the logic of science is the survey of some fundamental problems, and it is divided into 8 sections. First, we have the problem of induction, which refers to the challenge of justifying the use of induction in scientific inquiry. It is the question of whether induction inferences, which we may recall being singular statements concluded into universal statements, are justified. It is also the question of the validity or the truth of universal statements based on experience. Popper says that a principle of induction cannot be a purely logical truth and must be a synthetic statement, which leads to an infinite regress when trying to justify it. He also rejects the idea that inductive inference can attain some degree of probability and instead develops a theory called deductivism, which states that a hypothesis can only be empirically tested after it has been advanced. To further elaborate this, he then distinguishes between the psychology of knowledge, which deals with empirical facts, and the logic of knowledge, which is concerned only with logical relations. He then argues that the confusion between the two leads to the belief in induction logic, which he further discusses in the next section. As previously mentioned, Popper distinguishes between the psychology of knowledge and the logic of knowledge, where the former is concerned with the processes of how a new idea occurs to a person, while the latter is concerned with the logical analysis of scientific knowledge. He argues that the process of conceiving a new idea is not relevant to the logical analysis of scientific knowledge, but rather the methods and results of examining it logically. The focus of the logic of knowledge is investigating the methods employed in testing a new idea to be seriously entertained. The question of whether it is the role of epistemology to produce a rational reconstruction of the process by which scientists arrive at new discoveries is discussed. Popper says that it depends on what exactly we want to reconstruct, because if we want to reconstruct the processes involved in the stimulation and release of inspiration, then it is more likely that this is the realm of empirical psychology rather than logic or epistemology. However, if we want to reconstruct the subsequent tests and judgments that the scientists make in order to determine whether their inspiration is a valid discovery, then this could be seen as a kind of rational reconstruction of the thought processes involved. There's no logical method of having new ideas or a logical reconstruction of this process, and every discovery contains an irrational element or creative intuition. The deductive testing of theories is a method of critically testing theories and selecting them based on the results of tests. Always proceeds by drawing conclusions from a new idea tentatively put forward through logical deduction. These conclusions are compared with each other and with other relevant statements to find out the logical relationships that exist between them. There are 4 different lines along which the testing of a theory could be carried out. First is the logical comparison of conclusions among themselves, by which the internal consistency of the system is tested. Next is the investigation of the logical form of the theory, with the object of determining whether it has the character of an empirical or scientific theory, or whether it is tautological. Next is the comparison with other theories, which aims to determine whether the theory would constitute a scientific advance once it survives the tests. And lastly, testing the theory through empirical applications of the conclusions derived from it. The purpose of testing the theory through empirical applications is to find out how far the new consequences of the theory stand up to the demands of practice. Positive decisions, which are when singular conclusions turn out to be acceptable or verified can only temporarily support the theory, as subsequent negative decisions, or when conclusions are falsified, may overthrow it. Next, Popper discusses the problem of demarcation and the criteria for distinguishing between empirical sciences, mathematics, logic, and metaphysical systems. Popper rejects inductive logic as a suitable criterion for demarcation, arguing that it does not provide a distinguishing mark of the empirical, non-metaphysical character of a theoretical system. He sees that, he sees that problem of finding a criterion for demarcation as a fundamental problem of the theory of knowledge. Popper criticizes positivists' attempts to discover a difference between empirical science and metaphysics based on naturalistic interpretations. Instead, he proposes to formulate a suitable characterization of empirical science that would enable us to distinguish it from metaphysics. Popper's criterion of demarcation is a proposal for an agreement or convention, and he admits that his proposals are influenced by value judgments and predilections. However, he hopes that they may be acceptable to those who seek logical rigor, practical applicability, and freedom from dogmatism. In experience as a method, the difficulties in formulating a definition for the idea of an empirical science are discussed, as there are many theoretical systems with similar logical structures to the accepted system of empirical science. Three requirements for an empirical theoretical system to satisfy are outlined. It must be synthetic, so that it may represent a possible world. It must also satisfy the criterion of demarcation. For example, it must not be metaphysical, but represent a world of possible experience. It must also be a system distinguished from other such systems through the fact that it has been tested and has stood up to tests. Thus, experience is seen as a distinctive method that characterizes empirical science in addition to its logical form. The theory of knowledge is described as a theory of the empirical method or experience. Next, Popper discusses falsifiability as a criterion of demarcation for empirical science. He argues that the verifiability criterion of demarcation is insufficient and instead proposes that a scientific system should be capable of being tested by experience and refuted by it. In other words, falsifiability should be the criterion of demarcation rather than verifiability, as opposed to inductivists' view of empirical statements being both verifiable and falsifiable. Popper argues that definitive verification of a scientific hypothesis is in fact impossible. He also addresses objections to this proposal, such as the possibility of evading falsification and the seeming negativity of the criteria. Moving on to the problem of empirical basis. This refers to the empirical character of singular statements and how they are tested. Popper argues that this belongs almost exclusively to the theory of knowledge and differs from other problems that concern the practice of research. He believes that separating the psychological from the logical and the methodological aspect of the problem can lead to a solution, where subjective experiences or feelings of conviction can never justify any statement, and objective logical relations among various systems of scientific statements and within each of them are what counts. And in the last section, Popper discusses the concepts of scientific objectivity and subjective conviction. He explains that scientific statements are objective because they can be intersubjectively tested, meaning that they can be tested by anyone and their justification can be understood by anybody possessing reason. He also distinguishes subjective experiences or feelings of conviction from objective reasons, stating that no matter how intense a feeling of conviction may be, it can never justify a scientific statement. He argues that subjective experiences can only be the subject of psychological investigation and that within science, they play no part except as an object of empirical inquiry. Finally, Popper notes that if we adhere to our demand that scientific statements must be objective, then those statements which belong to the empirical basis of science must also be objective and intersubjectively testable. This leads to the view that systems of theories are tested by deducing from them statements of a lesser level of universality, which in turn must be testable in the same manner ad infinitum. Although this may appear to lead to an infinite regress, Popper notes that the deductive method of testing cannot establish or justify the statements being tested, and he does not demand that every scientific statement must have in fact been tested before it is accepted, but only that it must be capable of being tested. The next chapter of Popper's book is about the problem of theory of scientific method. On the first section on why methodological decisions are indispensable, Popper argues that it is impossible to capture the purpose of scientific inquiry without methodological rules. Popper's view of a proper scientist must have a critical attitude and not one that dogmatically upholds a theory, where they may perhaps be believing that it is their responsibility to defend such theories against criticisms. No conclusive disproof of a theory can be produced, for it is always possible to say that the experimental results are not reliable or shall disappear with the advance of our understanding. The next section on the naturalistic approach to the theory of method discusses that positivists critique the idea of having meaningful problems to be dealt with by a genuine philosophical theory and that there should be a methodology. Popper says that if the only meaningful problems are those found in natural science, then any debate about the concept of meaning will be meaningless. This is because the person in question would not consider questions about meaning to be meaningful or relevant in the first place. Furthermore, positivists dismiss objections on them taking the concept of experience for granted without fully analyzing it, claiming that it is irrelevant since they do not pertain to empirical science. But Popper thinks otherwise. He interprets experience as the method of empirical science, and methodology should not be taken for an empirical science. The naturalistic view is rejected as Popper thinks it is uncritical since it fails to recognize that what we consider to be facts are actually conventions or agreements rather than objective truths. Lastly, on methodological rules as conventions, it is described as the rules of the game of empirical science different from the rules of pure logic. Two examples of such methodological rules are provided by Popper. First, the game of science is without end. So he who decides that scientific statements do not call for any further tests retires from the game. Second, once a hypothesis has been proposed and tested, it may not be allowed to drop out without a good reason, such as a replacement of a better testable hypothesis or the falsification of one of the consequences. When making such rules, the main thing to keep in mind is that the other rules of scientific procedure must not protect any statement in science against falsification. Some philosophical doctrines could be interpreted as hypostatizations of methodological rules. Many problems in theoretical philosophy can be interpreted as problems of method, indicating that methodological investigations are important in philosophy.
And now we are going to dive into chapter 3, wherein we are going to talk about theories. Theories are the nets cast to catch what we call the world, to rationalize, explain, and to master. These theories are not merely sets of symbolic statements. There are two kinds of statements to complete a causal explanation. First is the universal statement, in which this is purely based on natural laws. On the other hand, singular statements, which apply to the specific individual situation and which can be called initial conditions. So, what is initial conditions? This is from universal statement in conjunction with initial condition itself used to deduce the singular statement. And this is the cause of the event in question. And contrary to the initial conditions, this prediction describes the effect of the event. For example, a load of 2 pounds was put on a thread with a tensile strength of 1 pound that caused its breaking. Principle of causality is the assertion that any event whatsoever can be causally explained and can be deductively predicted. According to the way in which one interprets the word can in this assertion, it will be either tautological or analytic, or assertion about reality or synthetic. And such principle, according to Karl Popper, is metaphysical and that scientific, and that needed for the system he is proposing. Lastly, the methodological rule says that we are not to abandon the search for universal laws, for coherent theories and causal explanations, but serves as a guide to the scientific investigators in their work. Strict and numerical universality. Strict universal means everything comes from theories and natural laws. On the other hand, numerically universal are statements that merely describe a large set of individual cases, and these statements claims to be true for any place and any time and refers only to a finite class of specific elements within a finite individual or particular temporal region. Karl Popper acknowledges that some philosophers do not agree with this distinction, but nevertheless, the rules of nature cannot be proven in practice due to the enormous amount of possible events whose adherence to the law would need to be checked. Next is the universal and individual concepts. In the section 14, Karl Popper then draws a related distinction between the universal and individual concepts. For instance, the planet versus the Earth. Coordinates in time and space, he notes, are kind of individual concepts. Popper cautions that this distinction must be kept in mind to avoid confusion about the more general distinction between universal and singular statements. There are two types of theoretical systems. First is the axiomated system, and next is the axioms. Axiomated system is the reason why the form of a rigorous system is aimed at. The form which Hilbert, for example, was able to give to certain branches of theoretical physics. Next is the axioms. Axioms is the attempt made to collect all assumptions which are all needed, but no more to form the apex of the system. These are chosen in such a way that all the other statements belonging to the theoretical system can be derived from the axioms by purely logical or mathematical transformation. A theoretical system may be said to be axiomated if a set of statements, the axioms, has been formulated which satisfy the following four fundamental requirements. First is the system of axioms must be free from contradiction, whether self-contradiction or mutual contradiction. Next is the system must be independent. Next, the axioms should be sufficient for the deduction of all statements belonging to the theory which is to be axiomated. And lastly, it is necessary for the same purpose, which means that they should contain no superfluous assumptions. However, C and D assumptions are two conditions that concern the axiom system as such as regard the relation of the axiom system to the bulk of the theory. There are some possibilities of interpreting a system of axioms. Axioms can be viewed into two basic ways, as conventions or empirical hypotheses. If treated as conventions, then they essentially define the different parts of the theory and restrict the values of the variables that can fit into those definitions. If treated as empirical hypotheses, difficulties arise because it is unclear how to proceed from the universality of the axioms to the specificity of individual objects or events. Lastly, the levels of universality and modus tollens. It says that within a theoretical system, statements can be ranked in terms of their universality, with axioms at the highest level. Then, less universal statements are deduced from more universal ones, and the falsification of a less universal statement implies that falsification of more universal ones from which it is deduced. The logical rule by which this falsification proceeds.
Moving on to the last part of the report, which is about the falsification theory of Karl Popper. To start off this discussion, I would like to first ask you a question. Does science provide us with a universal truth? For some people, science does not give us a universal truth. In fact, people who subscribe to conventionalist view believe that science, just like any other field like that of astronomy, is just a matter of general agreement. So as a formal definition, conventionalism is a philosophical theory that suggests that truth and knowledge are created by social conventions and language, rather than by objective reality or natural laws. They believe that even with science, the truth is relative. They do not believe that science is founded by pure logical reasoning, but rather that the knowledge that we get from it is a result of a convention. So for example, to say that there is a worsening global warming phenomenon only becomes a fact when the majority of the people accepted that premise. But this makes conventionalism problematic, right? Because thousands of people saying that the sky is green and not blue does not make the proposition correct. A whole country saying that the earth is flat also does not make it true. If all truths are relative, then how can we be able to settle divisive and crucial questions? In other words, there are two problems with conventionalism. First is that conventionalism presupposes that truths are relative. And the second is that conventionalism does not distinguish between provable or unprovable claim. This means that the idea of groupthink is a sufficient factor to establish a truth, even if it means not looking at other evidence that would suggest otherwise. According to Karl Popper, it is harmful to say that science is just mere agreements between the scientists or among researchers, because there is actually a way to settle empirical questions without relying on what the majority says or thinks. In his book, science is seen not as a fixed system or a mixture of generally accepted claims. He saw science as a dynamic thing, and for him, science is defined by the methods it uses to arrive at a conclusion. So we'll give an example. Take for example the question, are vaccines effective? Some people may say that it is only a scheme of big pharmaceutical company to make themselves rich. Others would say that it builds immunity and helps the human body fight off diseases. So the question is, should we let both sides believe their own truth? Or is there a way to come up with a conclusion that is universal? If we put our mind similar to a conventionalist standpoint, we would say that as long as the majority agrees, then vaccines may or may not be effective. I could only imagine Karl Popper disagreeing to these people by saying that this question begs further investigation, or what he called falsification. Falsification therefore occurs when scientific theories are not confirmed or verified by evidence, but rather can only be falsified or disproved. So to find out the truth about this question, he emphasized to look for empirical evidence in the form of observation or experiment. If a theory can be tested in this way, either by observation or experiment, then it is scientific. So to settle the question, are vaccines effective? Karl Popper suggests that we look for evidence that would prove that vaccines are not effective. If no or little evidence against the claim is found, then only we can say that vaccines are indeed effective. So how about the question that God exists? Can we falsify that claim? The answer is no, because that subject is not within the empirical realm. You cannot use any of your senses to prove or disprove the question of whether God exists, and therefore, it is an impossible question to settle. So these are the guidelines of when we will know if a claim is falsifiable or not. It is by looking at the different types of statement. The first is tautological statement. A tautological statement is a statement that is always true by definition. For Karl Popper, this statement cannot be falsified because it adds zero knowledge to us. An example of tautological statement is, a bachelor is an unmarried man. Since you cannot disprove such a statement, this cannot be a subject of falsification. Next is contradictory statement. A contradictory statement is a statement that directly contradicts another statement or is logically incompatible with it. Just like tautological statement, it is impossible to falsify this kind of claim. An example of contradictory statement is, my daughter is a boy. Since the statement is logically incompatible, you cannot falsify it as well. And the third and last statement is contingent statement. For Karl Popper, it is the only statement that can be subjected to falsification process. A contingent statement is neither necessarily true or necessarily false, but is dependent on certain conditions or circumstances. A contingent statement is true in some possible circumstances and false in others, depending on the facts of the matter. For example, the statement, it is raining outside. It is contingent statement because its truth depends on whether it is actually raining outside. If it is raining, then the statement is true. But if it is not raining outside, then the statement is false. For Karl Popper, the process of falsification only applies to this kind of statement. So to summarize, when it comes to the theory of falsification, we should be looking at 2 points. First is whether or not a statement or question is contingent, which means that the questions must have the quality of being falsifiable. And secondly, Popper emphasized the presence of counter-experiments and alternative hypotheses, where he said, as regards auxiliary hypotheses, we decide to lay down the rule that only those are acceptable whose introduction does not diminish the degree of falsifiability or testability of the system in question, but on the contrary, increases it. That is the reason why in our research subject, we always look for 2 hypotheses, null and alternative, whereas the purpose of alternative hypothesis is to increase the testability and strength of the null statement. Popper likewise advised us to accept or reject experiments in light of counter-experiments. That is the difference between science and pseudoscience. Science is an ever-changing process of disproving theories through observation and experiment, while pseudoscience is considered a fixed system that doesn't need to be questioned. And that's all for our report. Thank you for listening.